instead of saying, before I said 2 millicuries of radium-226, now I'm going to change this. I'm going to say, I'm going to make this cesium-137, and I'm going to say 4 millicuries, and I'm saying that this, now in order to do that, I'm saying 4 millicuries, so we still have to know what is the exposure rate for 1 millicurie, and do you guys know?
3.26.
3.26. 3.26 Rankins per hour per millicurie at 1 cm squared away. Right? So now we have 4 of them, what would it be? If we have 4
times.
4 times that. Exactly, at 1 cm away.
Right.
Guys, good, you're getting it.
It's like 13.
So now what? I'm not going to write it on the board, but now what if I said iodine 125? You had 4 millicuries of iodine 125.
It's going to be 1.46 times 4.
1.46 times 4. And where'd you get the 1.46?
That's your exposure rate.
That's your exposure rate that's in con that you should have memorized, or you will memorize before the exam. Very good. Good. So now let's get to the next thing. What if I were to change this? Let's go back. And let's make it 1 millicurie back. Make it 1 millicurie. And instead of 1 cm away, I'm going to say it's a total here of 2 cm away. What is my Rankins per hour? So it's a total of 2 cm away now from cesium-137.
Okay. So at 1 cm we were 3.26.
Yep.
Now we're going 1 more cm.
Yes. So what happens?
The further the distance, the less intense.
So yes, it's going to be less intense, correct. How much less intense?
Double your distance, a fourth less.
Double your distance, a fourth less. So if you're doubling it, but really what we're doing here is we're saying it was right here. We're saying we have a reference point here. At this location here, we know that it's from 1 millicurie is 3.26 Rankins per hour, right? And then we're doubling that distance. So really what we're doing is we are inverse squaring that, right? So what we're saying is it was at 1 cm away, now it's at 2 cm away, you square it, and that's going to be 1/4. Does that make sense? Alternatively, you will be used to seeing this as this over d squared. You remember this formula? You can say that your exposure equals that times your activity.
Right.
In this case, the activity is just 1 millicurie, so I didn't bother writing it. But it's that, or actually, I think that you guys probably write it this way. Not that it really makes a difference.
Yeah.
I don't know, but same thing, same idea.
Okay.
But why does it work that you don't have to do 1? See, in my equation here, what I did was I did
0.5.
I did the distance it was to the new distance it is squared, right?
Okay.
In this one, I'm just using 1d. I'm just saying d, really it's d2 squared. Why didn't I use d1 in this formula? The reason is because d1 for your gamma factor is always defined at 1 cm.
Right.
So that term falls off. In reality, all you're doing is inverse square in this formula. You're just not putting the d1 here because d1 is always 1 cm, so you just ignore it. As long as this is in cm too, Your d2 you have to write in cm too if you're going to have your gamma factor. If I were to say that this was 1, and I were to say this whole thing was 1 meter.
Okay.
You can't say 1 over 1 meter squared because that's 1 cm that's really sitting there. You have to say 100
centimeters. Okay.
100 centimeters squared. Does that make sense? So, good. So let's do this. Let's say.
So get to my
So
problem.
that's 2.45, right?
This
3.26 times 0.25 times a quarter.
Yeah, times a quarter. Yes.
Okay.
1 over 4
Yeah.
or a quarter. Yeah. Oh, you guys caught on to that very quickly. Good. Okay, so I'm going to take a couple steps back and get away from this formula. We'll come back to this a little later.